Number 13, we have to know if these expressions are equivalent to 2x squared over 3y squared z to the 7th, and check all that apply. Okay, so look at these things in pieces, and I would suggest looking at the simplest pieces you can as much as possible. Okay, so 2 thirds, 2 thirds. Then we look at the x's, x to the 5th over x cubed. Okay, that's x to the 5 minus 3. Okay, those are equivalent, so it's just x squared. So that part we have here. Then we look at the next part. We have a y squared over y to the 4th. So that is 1 over y squared, or a y squared in the denominator. Okay, so we have that piece as well. Then the last thing to check for is the z's. So z to the negative 3 over z to the negative 4. Alright, bunch of ways to try to figure this one out, but let's make those both positive exponents. So z to the negative 3, put that in the denominator, and it would be z to the 3rd. Z to the negative 4, put that in the numerator, and it becomes z to the 4th. And when we simplify those, we get z to the 1st, which is not z to the 7th. So the first one is not equivalent. I'll put a X there. Alright, next one. I have everything in here is being raised to the -1 power. So what is that going to do? Okay, first of all, realize that everything in here has a power. If it exists, it has some power. It may just be a 1. If it's a 1, we don't write anything. If it's anything but a 1, that's when we write it. Okay, so what happens when I multiply, so a power to a power, I multiply those. So it would be 3 to the -1, x to the -1, y to the -5, z to the -2. So what's going to happen to all those things? Remember back here where we had negative exponents, like that -3, we put that into the denominator to make it a positive exponent. So this 3 to the -1, I'm really going to need to move that down into the denominator. So what in the x to the -1, same thing. Everything's going to the denominator. And everything in the denominator, because of that -1, is going to change signs as well and go to the numerator. So if you see that, what you can do here is simply flip everything upside down. 2x cubed, y cubed, z to the -5th. So that comes up here. This will come down here. And what happens to that exponent, the -1? It becomes positive. Y to the 5th, z squared. Okay. So you can do that. If you see a negative exponent, you can just flip everything, and the exponent stays, but it's positive now. So all these things are being raised to the first power, but that doesn't change them, so we just leave it. We don't need this anymore. We took care of it when we flipped the fraction. So we got the 2/3. I'm going to maybe start simplifying it down here. So I have the 2/3. Good. All right, well, x cubed over x, that's going to be x squared, because that's just x to the 3 minus 1. You subtract those powers. Okay. Same thing, you have a y cubed over a y to the 5th. So if I subtract those powers, I get y to the -2, which is a y squared in the denominator. Okay, and just also, the way I do it when I have something like this, I look for which one is larger, the 5 or the 3. 5, clearly. So whatever y's I have more in the denominator than I have in the numerator, so I find the difference. 5 minus 3 is 2, and that y to the 2, or y squared, is in the denominator because there were more y's there to begin with. And then we have z. Let's switch back to green. We have a z to the -5 over a z squared. So we subtract those exponents. We get z to the -7. which is just 1 over z to the 7th. So now that's a z to the 7th in the denominator. All right, 2x squared over 3y squared z to the 7th, boom, that is equivalent. Okay. This one right here on the right, 2/3, good. Okay, so simplify the numbers first, then look at the x's. X to the 4th over x squared. That will simplify to x squared. Okay, 4 on the top, 2 on the bottom. 2 of them cancel out. There's 2 left on the top. Okay, the negative exponents here, we can flip those and it would be y squared over y to the 4th, or, which is equal to 1 over y squared, or we could look at it as y to the negative 4th minus negative 2, which is the same as negative 4 plus 2, which is y to the negative 2, or 1 over y squared. Okay, people tend to mess this up, so perhaps turning them into positive exponents first and then simplifying might be the best way to go, but you can do it either way. Same thing here, the z to the negative 3, you can put that in the denominator and make it z cubed, and then just add those exponents. 4 plus 3 is 7. And so that one is equivalent. And coming back over here to the far left. Okay, so negative exponent. So what can I do? I can put that in the denominator, and the exponent. So all that's in the denominator now, and the exponent is just positive. Okay? Look at the numbers first. 3 is being squared. So I got the 2 in the numerator that I need, but when I square 3, I get 9. 2/9 is not 2/3, so nope. Alright, now let's try this last one here in the middle. Alright, negative exponent. What does it do? Puts this thing into the denominator since it started in the numerator. And it would be to the first power, but when I multiply two or exponents by 1, they stay the same. So don't bother with it. So that's going to be 2 over 3. X to the 4th over x squared is still x squared at the top. The y, I only have one y in the top and 3 in the bottom, so that's going to leave me a y squared in the denominator. Then I have 3 z's in the top and 10 in the bottom, so 10 minus 3 is 7, also in the bottom, and boom, that one is correct as well. Okay, that one was a long one. Pick back up with number 14.